I'm gonna record either way, so no offense taken.
Show must go on.
I think it was like I'd be a little more like inspired if it was tournaments or something.
Not the first matches of the year.
Yeah, first match of
going
the year.
to look a little bit rough.
Yeah. So, okay, so we finished chapter 15. We took the test. Now we're going into chapter 16, which is basic probability. Okay. We'll touch into probability. And with this, then we will look at and consider what the difference is between probability and what's the other word we've talked about before? Odds. Okay. So probability, if we talk about, so 16.1, we talk about flipping a coin, right? So when you flip a coin, you have two outcomes. It's either heads or tails. You say, oh, what's the probability that it's heads? Well, the probability that it's a heads in this case would be 1/2. And so what it is however, I change it every year, I think, when I talk or, about it. It's total outcomes on the bottom. Total outcomes, right? Because you could either have a heads or tails on the bottom. And then the top is not necessarily desired, but I guess what you're looking for. So it's like, you could say desired outcome. So in that case, you have two options, heads or tails, over the total outcomes. So 1/2 would be the desired outcome of the heads, or the desired outcome of the tails, whichever one you're looking at. So if you're rolling a die, a typical 6-sided die, right, the probability of rolling a 2 would be 1 out of 6. Right? So then odds, odds is where you would see the odds, like in horse racing. Typically is where you see odds. Probably mentioned this last year talking to you, but the odds, is a little confusing because you'll see that the horse maybe has a 3 out of 2 or something. Right. 3 out of 2. If you think of probability, that doesn't make any sense because 150% chance that it's going to win. So the odds are not that. Odds are desired, right? Over not desired, I guess. Mm-hmm. Now total, it should equal the total number of outcomes, possibilities. And odds in the horse racing change, not based off of like there's 6 horses, so it's a 1 out of 6. It's based off of actually like that this horse is typically the slowest horse, in all these types of races, so it has a really low chance to win. They mess with the odds, so it's not as clean cut as rolling a die,
Yeah.
So in the case of the heads, for odds, if you're doing the heads, it would be the odds of rolling a head, or the coin, would be a 1 out of 1 there. So, okay, when we're talking probability. I just like to distinguish that just as a matter of principle when you think about, probability stuff. Okay, we've talked about, we know a standard deck of cards is how many cards in it? 52, then if you add jokers, but usually we don't refer to jokers unless they state it. So 52 cards, we know that there's 4 suits in there because there'll be questions about that, right? When they talk about a standard dice or die, right, it has 6 sides, and then they'll talk about, and they have a chart in there if you roll, a red die and a blue die and all the different possibilities for that. All right, some terminology they discuss. An experiment. An experiment would be, I'm going to roll a die. That's the experiment. A sample space of the experiment is all the outcomes of the experiment. So the sample space is like if I'm going to roll a die, there's 6 possibilities, right? 1, 2, 3, 4, 5, 6. That's the sample space. An event is any subset of the sample space. And so the event that you roll a 2, or the event that you roll an even number, that would be a sample space. And an event is any subset of the sample space. If the sample space of an experiment contains n equal likely outcomes, then the probability is denoted by, they give this thing. So you'll see notation, you may say like P of 2, and that if we're talking about rolling a die, what's the probability of rolling a 2? 1 out of 6. So you see that notation, P of 2 refers to the probability of rolling a 2 in this example. So, you can have a probability of 0, like what's the probability of rolling a 7 when you have a 6-sided die? It would be 0, right, over that number. Okay, so then we have things, they give some good examples. You can read through, I'll talk about them. Suppose a die is rolled, give a sample space for the experiment, and find the probability of rolling a prime number. What happens though if it's a probability of one of two events, meaning what's the probability of rolling a 2 or probability of something divisible by 2 or by 3. So if we were going to roll the die and then we were going to ask what's the probability of divisible by 2 or 3, the issue with this is that if you're going to roll the die, you have 6 outcomes, right? You have 1, 2, 3, 4, 5, and 6. So then what's the probability that it's divisible by 2? You would say, well, 2 goes into 2, 2 goes into 4, 2 goes into 6. So the probability that it's divisible by 2, if we just do that, that would be equal to 3 out of 6, right? There's 3 possibilities. And then we say, well, what's the probability it's divisible by 3? We say, well, a 3 or a 6, right? Well, the issue is that if we do it, we show it this way, divisible by 3 is their overlap. Plus 2 out of 6, right? So you're saying, well, 6 is actually divisible by 2 and 3, so there's overlap. So what we can do is we then subtract based off of like a Venn diagram. If we, you just took the test on that and remember where there's overlap. And then in this case, what did you do? You subtracted the overlap from these to come up with the actual value. So then you would have minus divisible, probability of divisible by 2 and 3. So what's the probability it's divisible by 2 and 3? There's one of those. And so then we end up with this probability of 2 terms. So if you have a divisible by 2 or 3, that's how we would do that. Now that is called a probability of either of 2 events. And they have this little theorem or I guess an equation of such. Probability of A or B, whatever the 2 events are, and it's equal to the probability of A plus the probability of B minus the probability of A and B. Squeeze that in there. So that's a little equation that can be beneficial on problems as you go and say, okay, I take individual probabilities if it's an or statement, right? Two events A and B cannot occur simultaneously, or 2 events A and B that cannot occur simultaneously are considered or called mutually exclusive. Okay. So if you were to say, what's the probability of rolling a 3 and rolling an even number, those are mutually exclusive, right? So if I said, what's the probability of rolling a 3, probability of rolling an even number, well, 3 and even numbers aren't the same, right? And so those are what we call mutually exclusive. There's no crossover. So 2 events are mutually exclusive if it looks like this. So P of A or B. So, and if it comes out to be this, P of A plus P of B, right? So if this is the case, then they're mutually exclusive. There's no overlap. If there is overlap, they're not mutually exclusive. So in this example, divisible by 2 or 3, those are not mutually exclusive because there is a number 6 that's divisible by both of them. Therefore, you follow this. But if there is no overlap, then you would eliminate this subtraction of that, and it would be just P of A plus P of B. Therefore, this is called mutually exclusive. So, for example, what we just said, probability that you roll a 3 or an even number, and you would say, okay, the probability of a 3 is 1 out of 6, the probability of an even number is 3 out of 6, right? And so you're equal to 4 out of 6, which is 2/3. And so since there's no overlap, you have no sort of subtraction of an additional thing like this. And if that's the case, then they are mutually exclusive. Oh, this is a good one. The probability of A, whatever it is, right? A or not A. This is like our complement principle. The probability of A or not A is 1. So it's like, what's the probability of a heads or not a heads? I'm flipping a regular coin. It's 100%.
Yeah.
I don't know, genuinely. I mean, it is possible, but I guess it could land.
Yeah.
Maybe. I don't know. I'm not sure.
Maybe it has to be like.
That should be your sound
Brand new
retire when you
price.
flip it one day and it lands.
I'll retire, absolutely.
Just do it like for 6 hours.
Every day. All
When we're all done at tennis.
Yes. So I really don't know. I've never heard it said, well, there is this, 0.0000. If there is a chance it could land on its edge, which I guess there is, it's so small that it's not really considered in these examples. So probability of A or not A, what's the probability of get a heads or not a heads? It's going to be equal to 1. Or what's the probability of get a 1 when I roll the die, or not a 1 when I roll the die? It's like, yes.
Yes.
Yeah, Jessie sent me 2 pictures. She's making a little picture book with pictures of the kids. And said, which one? And I had a picture of Johnny, a picture of Jared. I just wrote yes. So
Always the safe answer.
Yeah, not helpful. So, therefore, you could find the probability of A by going 1 minus not A.
Yeah.
Or you could probably find the probability of not A by going probability of 1 minus the probability of A. That's like our complement principle.
Yeah.
How many are divisible by 3 or not divisible by 3 or whatever those were, some of those questions. Okay, so that kind of discusses that. They have a nice chart on page 601 with red die and white die. When you roll 2 die, how many possibilities are there when you roll 2 die?
36.
36 possibilities. Yep, and you can see a nice chart there that you can follow. So let's take a look at page 603, which is your problems, and let's do just some of these together, because that way you don't have to write a bunch of stuff on the board. So on page 603, let's take a look at, suppose a card is drawn from a well-shuffled standard deck. I like how it always says a well-shuffled.
Well, that is.
Yeah, it is key. So a well-shuffled standard deck, and so then we're going to consider how many cards are in the deck. We already discussed this. There's 52, right?
Yeah.
So if I said, what's the probability? Look at number 2, let's say, a black face card. So when you're drawing from the well-shuffled deck, these 2A, you just say, okay, there's 52 possible outcomes, right? And then it says a black face card. Well, how many black face cards are there? It requires you to know a little bit about something. Yeah, there's 6, right? You have spades and clubs, and then jacks and kings, so you have 6. And then make sure to reduce, right? So it'd be 3 out of 26. Make sure to reduce those. Most of these are going to be given in fraction form, which is beneficial. I think it's, I don't know if it's beneficial. It's easier to grade when you have like a bunch of decimals going, so you don't round. But if you're going to talk in terms of percentages, usually it's, I don't know what would be easier, like telling somebody their chance that you got a 3 out of 26 chance, or what's 3 out of 26 on the decimal form?
That'd be like 11.8.
No, 11.5, but anyways. Like, what would be better for people's understanding? You're like, all right, I'm going to flip this card over, and just to warn you, you have a 3 out of 26 chance, or you have 11.5%. I don't know what people.
I feel like 11.5.
I think the percentage is usually
Just 'cause
like,
that's what we usually.
yeah, that's what we usually use. So, but this actually is rounded. So I think fractional is best for now. There are some, as we get into some of the stuff where it's like massively large fractions, so decimals are fine. But for our, when you go through, just leave them in fraction form for these ones. So, okay, so then a black jack. What's the probability for 2B, a black jack?
2 out.
2 out of 52?
Or 126.
So 126, right?
Or 3.83 repeating.
3.83 repeated. Yeah. That would be pretty close.
Pretty close, yeah.
3.85. So 1 out of 26. Now for part C, not a blackjack. There's a specific reason why they asked not a blackjack.
Because of the principle.
Because of the principle.
Yeah.
You could calculate how many are not blackjacks, right?
Yeah.
And that's not wrong. You'd be like, okay, there's, you know, whatever. You could think through all the cards that aren't blackjacks. Or you could be like, okay, if there's 2 blackjacks, that means there's 50 non-blackjacks, right? Which means, you know, or what they're really looking for you to do is just understand that if there's 1 out of 26 for blackjacks, there's 25 out of 26 not blackjacks. That's what they're looking for you to just probably mentally work through. Which is what percent?
You use my calculator on this one.
You don't want to be embarrassed again.
0.961538.
Yes. Okay, let's take a look at number 6. One of the integers between 11 and 20 inclusive on number 6. What does the word inclusive mean?
11 and 20 count.
It includes 11 and 20, yeah. So it's picked at random. What is the probability that the integer is divisible? Let's go with whatever. It doesn't really, these are pretty basic, but even. We can just do the first one. That it's even. So one of the integers between 11 and 20 inclusive is picked at random. What is the probability that the integer is even?
1/2.
Yeah. 1/2, yeah. So the key there is looking at a problem like that is just making sure that we understand 11 to 20 inclusive means it includes the 11 and 20, and this is where you would use the +1 principle. I think on the test somebody said the -1 principle, and they got one of the problems.
On this test?
Yeah. I don't know if they wrote -1, but I think they had 3,000
Oh, wasn't
and they
the,
subtracted 1 or something.
It was like all the numbers from 4,000 was
Yeah.
6,999 that have a 3 in it.
Yeah, and have a 3 in it, and then, yeah.
Oh.
So, somebody, yeah, did the -1 principle. So yeah, you would go 20 minus 11 is 9 plus 1, because it's inclusive, so there's 10 numbers, and then you would figure out that if there's 10, and then 5 of them are even, so you get 1/2.
Yeah.
So, okay. Whew. So then if we jump up to, let's go with like a, like 9 through 12. It says use the table on page 601, and that's referring to when you roll 2 die. And so there's this table that would help you. So if you look at like 9A, it says the sum is 6 on 9A. What's the probability that you roll 2 die and then the sum is 6? So you could go to your page over there on 601 and you see the whole breakdown of like rolling a red die and a white die. And then you just figure out that one die is 2, the other die is 3. But then don't forget, one die could be 3 and the other die is 2.
Is that what they do?
Except that's a sum of, I'm sorry, what did it say? A sum of 6?
Sum, yeah.
I was thinking 5. So a sum of 6, right? 3 and 3, or 2 and 4, or 4 and 2, so on and so forth.
Okay.
Have you ever played Settlers of Catan?
Yes.
So you know, like the robber is 7, right? But then on all the little pieces, don't they have dots? Like in the number 12 is 1 dot on it, and that's all based off of probabilities.
Yeah.
The 1 dot represents the least amount, or the lowest probability that it comes up.
Yeah.
So, okay, so you just follow the charts there to come up with your information on those ones, okay? So then let's go to the next page and just try number, well, since we're talking about the die, let's talk about 18. Suppose you roll 2 dice, each of which is a regular dodecahedron. With faces, they tell you what a dodecahedron is, faces 1 through 12. So what is the probability that the sum of the numbers showing is 24? So this would be, just think about like it's a regular die 1 through 6, now it's a die 1 through 12. So before we had 36 options, now with 2 dice of 12 on sides, how many options are we going to have? 144. Yeah. So in a dodecahedron, what's the sum going to be of 24?
Oh.
0.04%.
I mean, how many options are there?
Just
One, right? There's just one option to get 24 out of the 144. So then what's the probability the sum is 23? I mean, you think about it, you have 2 dice. To get to 23, you could either have a
148.
You could either have a 12 and 11, right? Or you could have an 11 and a 12.
164.
Or you could have a.
That's it, right?
That's it, yeah. So there's how many?
1,
2.
Okay.
72.
2 out of 144. So there's only 2 options, and then there's 144, so it'd be 1 over 72. Yep. All right, and then the last one, what is the sum? What sum is most likely to appear? Not actually 12, but you're honing in on it. Kind of like when two 6s are, I'm sorry, 2 die with 6 are rolled. What's the number that's most likely to appear?
7.
It's not actually 6, but it would be
So is it 13?
13.
Okay.
And the reason for that 12 is it doesn't work because you can't have 0 and 12. It's always going to be 1 and 12 or 12 and 1.
Yeah.
And then all the other ones getting to 13.
Yeah.
So you can get out 12, right? You could have a 6 and a 6. But the reason why it doesn't occur the most is you can't roll a 0.
Okay.
So that would be 13. All right. I think, does that make a fair amount of sense on most of these?
Yeah.
I mean, there's a lot of different types of examples that we'll have to work on, but that's the basics of it. So let me give you some HJEB homework for you. So they're just finishing warm-ups at the tennis match probably, so plenty of time to get over there and watch Big Fluff.
You know, it's a shame that when you hit a person, you win the point, because I'm sure Fletcher loses a lot of points when you
Okay. Numbers, this is on 16.1, 1 to 29, Bob. Skip 21. Ooh, spicy. Extra credit number 30. And then in addition to that, let's just tack on a couple evens on here. Make sure that we are not completely bobbing it. I guess as like ChatGPT, can you type most of these problems in and it'll give you the answer?
Yeah.
It will.
with explanations that sometimes make sense and sometimes do not.
Sounds about like my teaching.
Just about.
Basically, I'm Chat GTP.
Basically.
Okay, we'll just do those three. All right.
Okay.